Swayam Prabha. Digital India. Educated India.
So just to give you a little bit of idea about me, so I am from the Department of Computer Science and Engineering at IIT Kharagpur, and I basically lead the SWAN lab, the Smart Wireless Applications and Networking lab there. And so this particular lab, as many of you probably already are aware, not only in our country but also globally, is quite prominent in terms of the research, the different types of research that are being done on IoT. So our focus in this lab is particularly on the networking aspects. However, we also do some application-oriented projects. So for example, we have been executing projects in the healthcare. We are quite, we have quite a few achievements in the healthcare domain. We have also done some, application-oriented works on agriculture, underwater domain, and so on. So, so like this, actually, mining also is another one. Like this, actually, there are so many different, projects that we have been executing since the last couple of years. However, our main focus is basically the core research on the networking aspects, right? So the not, I mean, so application-oriented aspects are of interest to us, but I think most of our students take more interest on the actual innovations that have to be brought in to enable the networking of the different IoT devices. So this is basically I do what I do, and today, along with me, there are two other researchers from the SWAN lab who are also present, who will be presenting some kind of a tutorial uh, after my talk. So one is Dr. Nurjaman Ahmed. He is a postdoctoral fellow working with me in the SWAN lab, and another PhD scholar, Mr. Onteo Sarkar. So both of them, they will be presenting a tutorial on some of the advanced aspects of networking of IoT. So something called programming of IoT, programmable IoT, and also software-defined networking for IoT. So right now, actually, my talk is being pitched for those of you who are new to IoT and who would like to get exposed to what is out there and the kind of research, so it's a little bit of exposure about the introductory aspects and the different types of research that are being conducted around with IoT and so on. So just in the sake of, for the sake of completeness, let me just give you a little bit of introduction in terms of definition. What is IoT? Basically, IoT, there is no one standard definition of IoT, by the way, right? So there are so many different definitions floating around for IoT, and partly probably due to the way IoT evolved over the years, right from its beginning. So probably due to that, or there may be many other reasons. So we still do not have a single standard also for IoT, right? So there are so many different efforts that are being undertaken towards standardization. There are some bits and pieces of standardization efforts on certain myopic aspects of IoT, but IoT as a whole, there is no single standard that we can talk about. So what is this IoT? So there are so many different perspectives of IoT, but in general, so what people think about IoT is basically, as the name suggests, Internet of Things. So it's basically an internetworking of different things, right? This is what people try to think of IoT to be. So internetworking of different things. And these things are basically the physical things, anything and everything that you can think of, right? So right from the toothbrush that we all have used in the morning to to the different things like the air conditioning system of the room, the heating system, the air conditioning system, the lights, the cars, the different other vehicles. If you are visiting a hospital, the different infrastructure in the hospital, or anything and everything that you can think of are all candidate things in the domain of Internet of Things. So IoT is basically an internet network of different things. So it's a connected network. It's a connected network system, and of embedded objects and devices. So basically all these physical objects, the whole idea is that for certain reasons, you want to connect all of them together in the form of a single network or a big network, right? And the interconnection has to be done in such a way that there is seamlessness in terms of connectivity. So basically, even if you have a lot of heterogeneity, if you have a lot of disparity in terms of the network devices, protocols, standards, etc., but this connectivity end to end has to be very seamless. So this is the whole idea. So seamless interconnectivity of different physical embedded objects and devices with identifiers. So these devices and the objects, they also need to have certain identifiers, right? In the same way as in the field of computers and the computer networks, basically we have these computers having different IP addresses for identification. Here also, in the domain of Internet of Things, we need some kind of an identifier. So the other important aspect to highlight is that this system should be completely autonomous. There should not be any human intervention, ideally. So this is what people strive to achieve in terms of autonomy. So people try to achieve complete autonomy. However, in practice, it is often felt that complete autonomy is difficult. So people strive to achieve like partial autonomy of the system that they develop. So so there are different isolated standards, isolated communication protocols that are there. So they all will have to be fit into this particular framework. And as I said before, that the communication the communication network will be completely seamlessly connected and in a ideally fully autonomous manner. So like this, actually, there are many other definitions floating all around. If you search in the internet, you will find lots of different varieties of different definitions of IoT. So consequently, what happens is that, if at any time you are asked, like, or if I am asked, what is IoT? I cannot really be very precise about what IoT is. I cannot tell that only this much is IoT, this is not, and so on. So because that's not the case, right? So there are so many different different did anybody try to speak anything? Okay, so so there are so many different viewpoints that will also have to be included. I cannot really say that only this much is IoT and this is not, and so on and so forth, right? And another thing that I would also like to highlight, the beauty of IoT is the issue of ubiquity, right? So I might be sitting in Kharagpur, and I might be able to get the data or even operate upon a particular machine or a device that might be located over my IoT network, let us say in some remote part of the world, let us say in Los Angeles or somewhere else, right? So so it's basically it's going to be a completely ubiquitous kind of network, and this is already happening. This is something that is the beauty of IoT, and we have already experienced this in different projects, right? So so this is so far so good, but the main problem is that already with the computers we were running out of the identifiers, right? We were running out of the IP address. We were seeing that with the growth in the number of computers, IPv4 became insufficient, right, in terms of the addressing space. So IPv4 evolved into IPv6, IPv6, IPNG, and so on. But even those latter ones also these are also not very suitable for use in IoT networks. The reason is that when we are talking about interconnectivity of things, the number of such things basically explode, right? So what happens is that if you are talking about just one home, right? If we are talking about a smart home kind of application, in just one home, we can have large number of devices, right? So if you want to really interconnect all of them, the number of such devices will run into hundreds. And then if you are talking about like a city scale kind of network with all the smart homes interconnected, so the number of such devices from all the homes, in a city, the number of such homes is going to run into several tens of thousands. So tens of thousands times each home having hundreds of devices, hundreds of appliances, hundreds of devices. So how you are going to offer separate, addresses, unique addresses to each of them? So so basically, what is happening is already with the computers, the humans were becoming the minority, and the number of computers was becoming the majority. And then when we are getting into the world of IoT, here, due to the number of such appliances and devices and so on and so forth being interconnected, this problem is basically exaggerated, right? So this problem becomes much more, right? So how do you handle this kind of problem? And this addressing issue is one thing that I told you, like this actually, the scalability in general, in terms of everything that you can think of in terms of networks, these are actually problems that are very much pertinent to IoT research. So in the future, we are getting into a world where there are going to be millions of applications that are going to be supported by billions of smart systems and run on trillions of sensors. So we are getting into such a world, right? Already with 2008 and so, there were more number of connected devices than people. And that I think by now, everybody knows about it. And in the IoT world, as I was telling you a short while back, in the IoT world, what is going to happen is these number of IoT devices, interconnected, sensor-enabled devices, are thrown into billions and trillions. And the problem is such that you do not know really how to develop such a network. So how do we handle this problem? So this is one aspect. We'll come to it once again. So our government, several years back, the present government, it started its work on developing smart cities. So it started with the vision of 100 smart cities. Different smart cities got developed in phases. Some smart cities were like brownfield cities, as they call, which means that the old cities, the previous, the conventional cities, those were technologically transformed to comply with some of the requirements of smart cities. Whereas some other cities were being or are being developed from scratch. So these are called greenfield cities. So whether it is brownfield or greenfield, smart city projects are already developed. These are being developed, and throughout the country we have many smart city projects that are being currently executed, and many of them are some of these projects are already in higher levels of maturity compared to the other projects. Not only in our country, smart city projects are going on around the world. People are talking about developing smart homes, smart cities, and so on. So, irrespective of which smart city you are talking about and which part of the world it may be located, one thing is very important. It's how the smart cities are developed. So one of the core technological components for developing a city into a smart city is the use of IoT. So this is where IoT is attractive, Internet of Things. So essentially, with the help of these smart, or the sensor-enabled interconnected devices, what you can do is you can transform the different segments of a city. For example, you can transform a hospital into a smart hospital. You can transform the traffic system into a smart traffic system so that you have smart, monitoring of the traffic, surveillance, and so on. You can transform the, power sector into, smart power sector with energy management, appropriate energy management, and so on and so forth. Like this, actually, you can think about smart, different things. For example, judiciary, you can have smart judiciary, you can have, smart hotels and whatnot, right? So anything and everything you can think about to be transformed into their smart counterparts. So IoT is one of the many different technologies that are required in this transformation. IoT is not the only enabler for developing smart cities, by the way. IoT is only one of the enabling technologies for the development of smart cities. So when you talk about IoT and IoT enabled smart cities, we are talking about smart governance. We are talking about, maybe smart agriculture, smart living for sure, smart people, smart economy, smart mobility, smart environment, and many other smart X, Y, Z. So many other smart aspects are possible, right? In a typical smart city. Now, the beauty of these smart cities and IoT enabled smart cities is that unlike the traditional counterpart where things were not interconnected, here there are some beautiful use cases that come up which make these IoT based solutions very attractive. So for example, let me give you one of the examples from real life. So many times, nowadays it is not happening due to the pandemic, but many times previously, those of us who have our kids going to the school, in the early in the morning, we drop our children in our cars to the school. Some of the children, they go by school bus or other vehicles. But while we are working in our offices or while we are at home, we are very much concerned about whether number one, my child is studying properly. Number two, the health condition of my child, whether my child hurts himself or herself while playing, right? So like this, actually, there are many concerns that are there. So let us say that accidentally some child hurts himself while at school, while during playing. Let us say during the games and sports, they hurt themselves. So typically, conventionally, what happens? The school will call the parents. Probably the school will first call the ambulance. The ambulance comes, takes the child. School will call manually the parents, okay, and they will inform. So we being concerned about the welfare of our child, hurriedly we'll be rushing through the huge traffic in a city and trying to reach the hospital to see what is going on, right? So this is a typical kind of thing that happens, and it happens to many of us. However, in the IoT world, if you are talking about a smart city, then what will happen is that you can have certain use cases which will which are very attractive and will cut across different application verticals. So for example, if I have a smart city implementation while my child is in the school, I would be able to get all the details about number one, whether my child is studying sincerely or not, whether my child is attending the classes or not, whether my child is hurting himself or herself or not. In case there is an accident, I would like to get notified automatically, not waiting for the school to call me and inform me. Automatically, if something happens to my child, I should be from my mobile phone, I should be able to know the condition of my child. I should, when the child is being taken in an ambulance, I should be able to continuously monitor the condition of my child. Which hospital the child is being taken to. Whether there are some doctors who are already seeing my child or not. If while the patient or the child is being carried in the ambulance, at that time, I would be interested to know whether there is any roadside traffic jam, congestion that is happening. So like this, actually, there are many interesting questions that might be answered very comfortably, very easily, in an attractive manner if we have proper implementation of smart cities, IoT enabled smart cities, right? So these are only a few questions that I mentioned. Like this, actually, you may be able to come up with a lot of interesting use cases of the implementation of IoT to develop smart cities. Not only smart cities, actually, similar kind of questions you can ask in the other things also. Okay, other you can ask in the other different applications of IoT as well, and you would be able to come up with interesting use cases. So the beauty is that in this particular example that I was giving you, this particular use case of continuously monitoring my child cuts across different application verticals like education, like transportation, because the child has to be taken in an ambulance. So on the road, what is the condition of the road, congestion, etc. So transportation. Number three is healthcare, obviously. And like this, actually, you might be able to think a little deeper, and you would be able to come up with different other verticals where this particular use case is going to cut through, right? So what is required is to have some kind of a convergence of different application verticals, some kind of a convergence of application domains. So cross domain convergence is very important, right? So you see that implementation of IoT, deployment of IoT systems is not trivial, right? So if you have to address interesting use cases, then you need to really develop them. And development of such use cases, development of systems addressing different use cases like this is not very trivial. It's challenging, and it will take several years in order to come up with interesting solutions. Now, let us go a little deeper and try to understand this issue of addressing that I was mentioning earlier. So IP address, there is a problem, right? So how do we come up with a different addressing scheme? So towards this, actually, there are a lot of initiatives around the world that different researchers they have taken, and so there are so many consortia, industry, academia consortia, and different academic research labs also have been working on to come up with different solutions for addressing. So there are two viewpoints of developing IoT systems. One is that whatever existing internet you have, you just extend it, you just scale it up in order to accommodate these new IoT devices. So basically, you are trying to scale up the existing internet, right? So this is one way in which you can develop your new IoT network. The other way is basically to develop a completely separate internet network from scratch, right? So you have a separate internet network of IoT devices which are going to be developed from scratch. Right? So there are a lot of initiatives, there are a lot of viewpoints, there are pros and cons in both, right? And so many different initiatives which basically prefer one over other. There are so many recommendations also that are floating around. But one thing is required, one thing is common in both, is how do you address, right? If you are extending and expanding the existing internet, then obviously, you will have to go with the existing, existing IP addressing mechanisms. So whether you want to interconnect IPv6 with IPv4 existing traditional v4 networks, then IPv6 or whatever. So whatever be it, so you have to address, and addressing is a huge problem in this particular domain. So this is one. The other aspect is, if you are developing something from scratch, then what will be this new addressing mechanism? You do not really need to fall back on the traditional IP addressing mechanism, right? So what will be the new? So there are so many different proposals that are floating around. One of the interesting ways of addressing is called use of attribute value pairs, right? So attribute value pairing, right? So it is a completely different way of thinking about how the addressing is going to be done. So like this, actually, there are so many different innovative ways in which people are trying to come up with new ways of resolving this traditional problem of addressing in the internet.
So,
Any question?
yeah, so we talked about having a separate internet world just for the IoT devices. Right now, with the trend in which we are going, most of the devices that we are using today are getting converted into IoT devices. So essentially, the next gen devices have been replaced by IoT devices. Then how is it efficient to build a new world of
No,
internet just for
these
IoT
are also
devices?
actually different perspectives. You are very right. As I also said, these are different perspectives, and there are pros and cons of both. So the way, as you have rightly said, that the way things have been moving forward is basically, you can think of IoT as an extension of your existing internet, right? So this is what is happening. So what you do is, whether you build it in your lab or you procure some IoT device. So ultimately, it has to fit into the existing internet, right? So this is the way. So ultimately, it has to get some kind of an IP address or something similar, and this is how it is happening. But there is already a problem, right? So there is already a problem of this IP addressing based addressing mechanism. So that is the reason actually people have been trying to think about what could be the other ways in which these are actually in the research stages, right? Most of the, as you have said, that most of the commercially available ones are still falling back on the existing internet to be connected.
Okay, sir. Okay, sir.
So yeah. So now the point is that how do you form the architecture of IoT, right? So what would be the architecture of IoT? So unlike, let us say, OSI for the internet or TCP/IP for the internet, so here we do not have similar kind of layered architecture. Here we do not have something similar. It is not standardized also. So there are different proposals floating around in different research papers and white papers. So one of these basically talks about, and this is a very commonly used one, that is why I picked it up. So one of these basically talks about these different 4 layers, right? So these 4 layers in the IoT stack. So at the very bottom, you have the sensing layer, then comes the network layer, then comes the service layer, and then the interface layer. So as you see, that sensing layer is a new one. So there was no sensing layer in the OSI or TCP/IP. So here you have a sensing layer, and this is basically a very important layer, because IoT, one of the important functionalities is basically sensing, right? So continuous sensing. So you have a dedicated layer for it, sensing layer. This network layer, we have seen this term in the context of OSI as well as TCP/IP reference architectures for the internet. But the scope of the internet, the network layer over there, as well as the scope of the network layer here, are basically different, right? So here basically the network layer talks about these isolated networks, right? So separate networks like wireless local area network, like wireless sensor networks, like cellular networks, other mobile networks, and so on. So these are basically part of this network layer, right? So basically the perspective is different, although the name is the same, the network layer, right? So that's the layer 2. Then layer 3 is the service layer. This layer is also, we have not come across similar names in the context of OSI or TCP/IP. So here you have a separate layer, service layer. And why we need the service layer? This is a very important thing. This is a very important layer. See, IoT is all about services, right? So why do you want to, adopt IoT-based systems in your applications? Because you want to offer improved services, whether you are talking about smart cities or smart homes or anything else that is smart, right? So you want to basically offer improved services. So there is a dedicated service layer that is proposed over here. Then on top, you have the interface layer. So interface layer basically talks about something very similar to what we used to have in the as the application layer in the OSI. So very similar to that is the interface layer. You can think of it as very similar to the application layer, where different applications and apps, etc., are going to execute. So this is basically the detailed view of all these different 4 layers. At the very bottom, you have the sensing layer with the RFIDs, intelligent sensors, and BLE devices, etc. These are all part of. So these basically these different sensing devices, they sense and they throw the data, which will have to be sent to the network layer, which will be used by the network layer. The data are going to be sent through some network, like let us say internet or mobile network, cellular network, or whatever be the network. So the data is going to be sent through the network layer. Then there is this service layer, which is going to talk about how these services are going to be offered. Different services are going to be formed. These services are going to be integrated, divided, and different manipulations and these different types of execution of these different services are going to be offered. So this is the service layer, and on top, as I was telling you, you are talking about the APIs, the front ends, and so on and so forth. So cutting across all these different layers is the security, right? So only security is mentioned, but I would like to think of it this way, that it is not just the security, but security, privacy, trust, all the three, S, P, and T. So S, P, and T basically cut across all these different four layers, right? So you have to ensure that if you are talking about service layer, let us say, right, you have to ensure that these requirements of security, privacy, and trust are taken care of. Okay, is this clear? Any question on this part?
What is the social network in the network?
These are actually these are actually like, so this is not Facebook or Twitter, right? So this is basically these normal, like, social different social networks may be formed, right? So nowadays, for example, social networks are formed for contact tracing, right, in the pandemic times. So different social networks being formed. So these are actually all, I mean, so between different social beings, the network that is being formed between different social beings, this is also part of the this is also one type of network that is also part of the network layer.
That is again formed underlying network is internet. So
say that again.
The underlying communication mode between these two social beings would be internet.
Yeah, so actually there is an overlap, as you are rightly thinking. So there is an internet, it could be internet, it could be something else, it could be, it may not be anything. So nowadays there is this concept of something called opportunistic network, right? So which is not purely internet, but so basically, where there is deviation from the assumptions that are made in the internet, right? So it could be an opportunity. So let us say that, so it could be, you can think of it this way, that there is a team of rescuers who collectively do something, right? So there is a disaster, and post-disaster there is some rescue effort, right? So the network that is formed out of these rescuers, so you can think of it. So they might be using some technologies which will be internet enabled, or wireless enabled, or whatever be it, right? So, but the thing is, the main idea is that conceptually these are like different types of networks, right?
Okay.
Now,
Excuse me, sir.
yes, please.
So in the previous slide, in the context of that example which you explained before, what can you please tell us what happens in the service layer?
Different services. So you have to think about. So I do not know. I mean, so this is something that you have to think a little deeper. So what is the service that is being offered in the context of the example that I mentioned? Can you name these services? What are the services being offered? So who are the actors? So let us think of it this way. Who are the actors? Who are the actors, and what are the use cases?
So use cases is getting notified when something happens to the child.
Right.
If the child is eating, if the child is sitting in the class.
Correct. Very right. And who are the actors? The parents, right? The teachers, the I do not know, maybe these ambulance operators, so like that. So as you can see that, so you can think about these corresponding to these use cases, or directly these use cases themselves. These could be the different services, right? The services being offered with the help of this IoT implementation, right? So how, so some of these services could be, if you are talking about like granular level services, they in order to fulfill a particular use case, these services might have to be integrated together. Okay, they will have to be put together, right? So in order to fulfill a particular use case, some of these services may have to be divided. So so you have to disintegrate some of the services, right? So like that, actually, there are different manipulations that you can do with these different services, right? In order to cater to the requirements of the application that is running on top. Right, so there are different applications are running. So in order to perform certain task, from that application layer, so basically, some of these services will have to be formed, and so you might be integrating, disintegrating, or whatever, dividing, etc. So like that.
Okay. Sir, the interconnecting security layers in between.
Could you repeat? I cannot hear you.
No. Am I audible, sir?
Yeah. Now you are. Say that again.
Sir, the interconnecting security layer, which are
interconnect. No. This part I don't understand.
Like cutting through all the layers.
Security. Right.
So, is this the internal version of the IoT services, or is the security is externally imposed on the network?
No. This is basically just a representative thing over here. So what it means is that you have to ensure that security is taken care of in each of these different layers, right? In the sensing layer, in the network layer, in the service layer, in the interface layer. You have to ensure that, let us say that you are talking about just simple sensing, right? So whether that sensing is secured sensing or not. In the network layer, you are talking about, let us say that somebody talked about social network, right? So whether that social network offers adequate levels of security or not, right? So you have to come up with protocols that will ensure security in that social network, right? So like that, actually, you have to ensure security in each and everything that you can think of in this in this kind of framework. Any other question?
Sir, the protocols used in the network layer is similar to TCP/IP, or else separate set of protocols are followed for
The
services.
right. No, so basically, this particular representation doesn't talk about whether you are talking about TCP/IP or whatever it is. See, if you are talking about TCP/IP, then so the network that is used is the internet, right?
Yes, sir.
So we are not talking about that. This is just a representation to show that so these are the 4 layers that will have to be implemented. Now in that network layer, if you are using internet as your communication network, if you are using internet, obviously there is this TCP/IP that will come into picture, right? However, if you are talking about, let us say, a sensor network, right, internet may not be relevant over there. Okay, so it all depends, right? So it's a different viewpoint, it's a different perspective of conceiving the different layers for IoT. It's you cannot really map to the OSI layers.
Okay, sir. Thank you.
Okay, can we go forward? Okay.
Yes.
Okay. So this is where we were at. So you see that ultimately, so IoT is all about sensing, right? And maybe there might be some actuation based on the sensed data that are received, processing of the data based on the processed data. There might be some actuation that may be required. So as shown in this particular figure, so you have some kind of a sensor network at the very bottom. So this sensor network basically continuously throws data out from these deployed devices. So this data will have to be dealt with. So like when IoT was becoming popular, at the same time, another technology that was becoming very popular is the cloud computing. So cloud computing became very popular in the last 10 years, right? Nowadays, it is something that is not in the research stages anymore. It is something that is very much used everywhere. Almost everywhere people are using cloud. Even like the students are also using cloud, right, in their in academic assignments, right? So everybody is using cloud nowadays. So you see that sensor network was good in terms of data acquisition. So you acquire the data and then you have to do something with the data. So conventionally, the data would have to be thrown into some kind of a network, some kind of a server. But with the popularization of cloud computing, what is being done is that because cloud is very good in terms of storage, in terms of processing power, and so on, and there are a number of other benefits of cloud also. But because of these different advantages of cloud, the integration of this sensor network or the sensors with cloud basically provides a very robust mechanism of not only data sensing and dissemination, but also processing and storage. So processing and storage, powerful processing and storage mechanisms are offered by cloud computing through different technologies such as virtualization, then different other constituent technologies. Plus there are different models, conventional models of software as a service, platform as a service, infrastructure as a service, and so on and so forth. And on top basically runs these different applications that we were talking about earlier, right? So this is this IoT cloud integrated framework that everybody talks about nowadays. So earlier, if you recall, when I started with the definition of IoT, and I said that ideally these systems, these IoT based systems should have full autonomy. So that means that there should not be any human intervention of any kind during the operations of these systems. So earlier, several years back, there was this concept of autonomic computing, which was becoming very popular. So companies like IBM, etc., they worked on autonomic computing. Autonomic computing became very popular. So part of this concept of autonomic computing were different properties such as, self-configuration, self-healing, self-optimization, etc., which were basically proposed as part of this vision of autonomic computing. So those properties and few others which are similar, these have been basically also proposed in order to grant full autonomy to these different IoT based systems. So in other words, there are some of these features that are listed on this slide that you can see, which are ideal features, which are desirable features to have fully autonomous IoT systems. So the IoT systems that we develop, we should strive to build these systems to be self-adaptive. They should be self-organized, self-configuring, self-healing, self-describing, self-optimizing, self-protecting, self-discovering, self-matchmaking, and so on and so forth, right? So these are some of these different self-properties which basically ideally should be implemented on these IoT systems. Okay. Now, yeah, okay. Now, I'm getting some part of my screen masked sometimes. Yeah. Okay, now it is better. Okay. Now let us try to think about the building blocks for IoT, right? So for the internet, we already know that there are different building blocks like the nodes. Nodes means like the different network devices, etc. The nodes, the gateways, the proxies, then different types of networks like LAN, WAN, MAN, etc. So here also, conceptually, you have to modularize this entire network architecture. Whereas in the internet, we have all these concepts. Here also in IoT, whether you are extending the existing internet or whether you are developing a separate internet network from scratch, we need to have this IoT node, IoT gateway, IoT proxy, local area network, wide area network, and so on and so forth. Very analogous to what we have as our internet counterpart. Excuse me. Now, let us quickly have a look through a simple prototype of an IoT implementation. So you see that all of us, we have our smartphones. These smartphones, as many of us, we already are aware that they come with different sensors. Some 3, 4, 5, 6 sensors are all there in most of the modern smartphones. Sensors such as temperature sensor, humidity sensor, then accelerometer sensor, gyroscope, camera sensor. So like that, actually many sensors are there in these modern smartphones. Excuse me. So what we have sensor enabled smartphones. Now, these sensor enabled smartphones, we can utilize them in order to sense whatever they are supposed to sense. So these sensors can be activated on the smartphones. These sensors are going to continuously sense the data and throw the data out of these devices. These data could be sent through the existing internet or a separate network or any other network, and would be taken to either a regular server or the cloud. Nowadays, everybody is using cloud. So basically, you can connect your mobile phone to the cloud, and at the cloud server, this data could be processed. At the cloud server, this data could be processed. So based on the processing, whatever is the result, so some kind of an actuation or some kind of a feedback can be sent back to the origin, that means the original smartphone, or it can be sent elsewhere for doing something else. So some kind of an actuation or something very similar would be done based on the results of analysis. So one is with the smartphone sensors. You can just let me complete this, then I will take your question. So the other possibility is that you could build, once you have, so this is like a small student project, right? And this doesn't cost anything. So you can very well, so nowadays cloud facilities are there everywhere. Even academic campuses also have their own cloud, or they have subscribed to some cloud, and everybody has a smart sensor, smartphone sensor, and all of these access to smartphone sensors. So this is an exercise that can be easily done. Now, another thing that will be also interesting, and this will cost a little bit of more money, is basically to develop a sensor node. So nowadays, all these Arduinos and Raspberries are all there. So basically, what you can do is you can use the processor in these devices. You can connect to some sensor, right? There are so many, off the shelf interesting sensors are all there. So these sensors can be connected, and just one. Okay, these sensors could be connected, yeah, so you can use these sensors, and there are so many different communication modules that are also there. Okay, so like Zigbee, etc. These are all available, right? So what you can do is you can use these, and you can build a small sensor node, right? You can build a small sensor node. So this small sensor node has this sensor component, this processor component, and the radio component. So all of these are there, right? These just give me a moment. I'm getting a call. I'll just send a message. So yeah, so these sensor nodes, they can send the sensed data again to the cloud server through the internet, and again some analytics, simple analytics like thresholding based analytics, or very simple analytics, right? Doesn't need to be fancy machine learning and all. So simple analytics like computing the average over a particular time span on time series data or whatever, right? So you do something, and then based on that some actuation can be done, right? So this is a very simple IoT implementation which can be executed, right? Some kind of a student project. Yeah, somebody was asking some question.
In the previous slide, when the business all the computation happens in the cloud server and the result is sent back to the origin. So is there no involvement of the internet, or I mean, how is it? How does
here actually, as I have shown here, whatever I have shown is basically all through, everything is through the internet, right? So because this is the way this, like, so if you are talking about a mobile phone nowadays, right? So either it uses the internet, right? Or it will use your cellular network. So some way it has to communicate. This is the way they have been built, right? So what I was telling earlier, I think if you are trying to relate to that, is that something else has to be developed from scratch, that is in the research stages, that is not commercially available yet, right? That's different from this thing. So now, if you are already using some existing commercial products, you have to use the technologies that come with it. You cannot really go and build something as you like in these devices, right? That is not possible.
the connection between the cloud server to mobile, just it says WebSocket. So this
no, whatever. I mean, so basically it's the internet. Just think of it like, through the internet only all communications happen. Right.
Okay, sir.
Okay. So now, so having told all of these things, let me now quickly give you a little bit of idea about what these networks are, right? So essentially, although theoretically IoT doesn't have to be all wireless, but most of these IoT based systems that we think about nowadays, or the ones that we try to build, these are actually wireless enabled. They're wireless systems, right? So typically these are wireless enabled systems. So these actually, not only these are wireless systems, but also the kind of wireless network that we experience in these are of a typical type. Okay, so let us try to understand first of all what are the different types of wireless networks. So if you are talking about wireless networks, typically these networks can be classified into two types, right? One is the infrastructure based networks, the other one is the infrastructure less networks. So these cellular networks that we use or the wireless local area networks, these are basically of the infrastructure based type. The reason is that you need to use some fixed infrastructure like base stations or some centralized network manager, etc., for the communication to be made happen. So this is one type, but the main problem with this type of network is that you really need to have the existing network infrastructure to be placed. So if you do not already have, so you need time to basically lay the foundation for such kind of infrastructure, right? So you cannot do it in couple of hours, let us say. So infrastructure less networks are the ones where really you do not need any centralized access point or base station, etc. So ad hoc networks are a type of infrastructure less networks where, as you can see on the right hand side figure, bottom right side figure, there is no fixed, centralized access point, right? So basically you have only a collection of different nodes. These nodes, they will be able to, in certain configuration, they will be able to, talk to each other, right? So that is the ad hoc networks. These are infrastructure less networks. Now, uh, you know, these ad hoc networks are very interesting because they can be set up very fast. And if you do not already have an existing infrastructure, you do not really need much planning in order to set them up. So basically, you just need these nodes to be there, and through certain basic configuration, basically these nodes, they can start communicating with each other. So these networks are typically self-organizing and self-configuring, right? And also there are a few other self properties that also hold good for them. So some of these properties of these ad hoc networks were borrowed forward and were taken forward and were used in something called the wireless sensor networks. In the sensor networks, we can think of the sensor networks to be like, ad hoc networks with some kind of sensors that are used as one of the components. So these are like sensor enabled, let us say, ad hoc networks, right? So although sensor networks do not have to be necessarily ad hoc in nature, but most of these sensor networks that we talk about in the research community, we are talking about ad hoc sensor networks or sensor ad hoc networks as they are typically called. Now, the thing is that here actually you have a large number of sensor nodes in a normal like ad hoc network. You only have like couple of laptops or couple of PDAs, etc. But when you are talking about a sensor ad hoc network, etc., you are talking about the deployment of large number of sensor nodes. So these sensor nodes, they may be, let us say that, for monitoring forest fire, right? So these sensor nodes, they may be placed or thrown or whatever, in some way they could be deployed in a particular terrain of interest, and then they will start communicating with one another, sensing the data around them wherever they are deployed, and the data are going to be sent to the server or cloud for further processing, right? So these are basically these sensor nodes. They are like they form the network in an ad hoc fashion, and they collaborate with one another, right? And then they measure the condition around their surrounding environments. So these sensed data are then transformed into digital signals and processed to reveal some properties of the phenomena that go, take place around these different sensors. So what you typically have in these ad hoc sensor networks is a multi-hop kind of communication system. So if a particular node has certain data that has to be sent to the destination node, and there is the destination is not within the direct transmission range of this particular sensor node, then it will have to take help of some intermediate nodes in order for them to relay the packet from the source node to the destination node. So this is basically this multi-hop path through which the data goes through. Now these sensor networks are of different types, stationary type or mobile type. So these are all there, but I'm not going to get into the details of those. But one thing that I would like to highlight over here is that each of these sensor nodes, they have a sensing unit, a processing unit, a transceiver unit, a power unit, and a couple of different application dependent units, right? So these are this is typically the constitution or of the different components of the sensor node. So why I wanted to mention about this sensor node and the sensor network is that when you are talking about IoT and sensor enabled IoT devices, Essentially, it's a sensor node, right? So if you are talking about a sensor-enabled IoT device, it is typically a sensor node, right? And then if you interconnect similar kind of sensor nodes, what you get is a sensor network. So you can conceptualize your IoT network to be like a sensor network. Obviously, because IoT networks and their research on IoT networks has evolved much more than the sensor networks. So there is a lot more to IoT networks than the traditional sensor networks. People nowadays are not talking about sensor networks much. Everybody talks about IoT networks nowadays. But conceptually, most of these properties of the sensor networks have been inherited into these IoT networks, and many more other different features have been made visible. So there are different sensors, so MEMS-based sensors. Nowadays, people are talking about NAMES-based sensors. So MEMS is basically micro electromechanical system. So NAMES is basically the nano counterpart of this. So people are talking about MEMS-based sensors, NAMES-based sensors. So these sensors, if you are talking about MEMS-based sensors, these sensors are very small in size, like with respect to the different reference points that are shown. So with so these are comparable to the size of, let us say, the fingertip, right? So in one of the pictures, as you can see, and that it is comparable to the size of the fingertip. So it's very small. And even if it is very small, it is like a small computing device, because it has a very small processor. It has a very small communication unit, so it has a very small battery, right? It has very small memory, right? Like that, so all these different things that a computer has, all these different components are also there in the small device, small sensor device, right? So this is what you find also in your modern IoT networks. And if you are building these IoT devices using off-the-shelf, open hardware platforms like Arduinos, etc., they're also the same thing. Arduino itself comes with the processor, right? So you get the processor, you take some sensor node, you just put it in one of the pins of that particular Arduino. So like that, actually, using certain configuration, everything is basically, so kind of plug and play, right? So everything, which pin does what and to which pin you should connect, everything nowadays has become very simplified with the popularity of these open hardware platforms like Arduinos, etc., right? So very similar kind of thing. So different applications, so right from environment monitoring to healthcare to industrial condition monitoring, equipment monitoring, etc. Everything can be done with the help of these sensor networks. This is a typical scenario, post-disaster scenario in healthcare. So what happens is, there are different patients in different places. You only have a couple of doctors and nurses. So how do you interconnect them, right? So these different sensors are there. So these sensors basically are fitted to these patients or other infrastructure. And doctors and nurses, even if they are very few in number, with the help of this technology, they can remotely, continuously together at the same time, they can monitor the condition of large number of patients, right? So this is basically an attractive application of these sensor networks. So although sensor networks are very attractive, there are some common challenges. One of the biggest challenges that I see is that of scalability. So theoretically, this is all attractive, but attractive to connect all of these nodes, and you are talking about hundreds of such nodes, thousands of such nodes, and so on. But there is a limit in terms of the network, right? So basically, if you are increasing the number of nodes, it has been shown in one of the papers that was published in the IEEE Transactions on Communication. If I remember, the year was 2002. It has been shown that in a multi-hub kind of scenario, the throughput basically decreases at the rate of 1 over square root of n, where n is the number of nodes in the network, right? So as you can understand, that scaling up is very difficult in these networks, right? But it is required. You need to scale up. So you need to scale up. You have to ensure that acceptable levels of service are offered to the clients in the presence of large number of nodes, right? So this is what is required, and it's a challenge as well. It's a research challenge. So people are working, different researchers have worked already. A lot of work has been done, and a lot of work will eventually be done in future to address this issue. Then comes the issue of, yes.
Can we form micro networks of sensors? As in, it's I understand when it is in large scale and throughput decreases, but there are some places where the sensor networks might be beneficial because there might not be a requirement for any layer, and we can directly interact with to get.
Yeah, that's right. So that's
Yeah.
right. So it is required, but it's a challenge, right? So this is what I told you also, that it's required. There are some benefits, but so
Are there applications, real-time applications that rely on the sensor network?
yes, of course. There are so these are like desirable applications, but so these applications, like let us say forest fire, the example that I was giving you earlier, right? So if you are talking about, I do not know how many of you are from Andhra Pradesh over here, but several years back, if you remember, you must have at least heard, even if you are not from Andhra Pradesh, you must have heard that one of their chief ministers, basically, they are in a bad weather condition. The helicopter basically crashed in one of the forests, right, in Andhra Pradesh, and rescue operations was very difficult, not only because of the bad weather conditions, but also because of the dense forest. It was difficult, right? But if let us say we had the sensor network technology matured enough at that time, then you can fly another helicopter which will throw away the small cheap sensor devices on the ground, and then they will self-configure. They will they will start their network on their own, right? And then so these rescue operations will become easier, right? This is desirable. This is one of the applications like this. Actually, there are so many different applications that are there where you need to really scale up beyond like tens of nodes, right? You need to go into hundreds or thousands probably, right? So how do you deal with it? So I do not have an answer for it because it is still in the research stages, and a lot of research works are being carried on. Everybody tries to come up with a solution which is superior to the other, and so on, right? So this is like commonly whatever happens in research. Okay. So the other challenge is basically quality of service. Quality of service from a network point of view means like you want to offer some kind of a guarantee in terms of bandwidth or delay or jitter or packet loss probability, etc. So offering some kind of a guarantee in terms of the network quality of service is very difficult, right? It's very difficult in these kind of environments wherever these nodes are deployed, because these environments are these have very difficult kind of very challenging channel characteristics, RF channel characteristics. So these channels basically, they have unpredictable changes. They go through unpredictable changes in their characteristics, and the network also is highly limited in terms of bandwidth, right? So these are, so how do you offer in this kind of constrained environment? How do you offer guarantees in terms of minimum, let us say, this much of bandwidth will be available to the users at all points, right? So this kind of guarantee is very difficult, right? So quality of service guarantees is a difficult thing. So another research challenge is basically energy efficiency. I think energy efficiency is something that everybody has tried to get some success on. So energy efficiency means like, so here actually, because it's a multi-hop network, you not only have nodes which will have to do their own little tasks that they are programmed to do, but also they have to cooperate with the other nodes, because here you do not have a centralized network entity or manager who will do the network coordination and so on, right? So every node has to participate as a host as well as a relay, right? So so that means that whenever you want to relay somebody else's packets, or other data units, if you have to relay those, then you need to consume your own energy. So so why would a node want to consume or consume its own energy in order to cooperate with other nodes? What are the benefits of it, right? So there may not be any apparent benefit, but at the same time, if these nodes did not cooperate due to these reasons, then the entire network is also going to collapse. So so this is again another challenge. So here actually there are a lot of reputation-based schemes that have been reputation-based schemes. And then what is it called? And different mechanisms of cooperation, basically different mechanisms of cooperation have been formulated in order to encourage these nodes to cooperate, right? So if basically if I cooperate, basically there are some incentives that I'm going to get, right? So that's something that so that actually a lot of research works have been done. Then comes the security. Basically, any wireless network basically is prone to a lot of different types of attacks because it's an open medium. Nodes are prone to malicious attacks, infiltration, eavesdropping, etc. Plus, in this resource constrained environment, really you cannot run your existing, security mechanisms like RSA or PKI, etc. So those, because those are basically resource consuming, right? Highly resource consuming. So here actually you need some kind of a lightweight kind of system to secure your network. So, coming back, so I talked about the sensor node. Now, whenever you are talking about IoT, so IoT, most of these IoT nodes are basically transducers, right? So they take some input signal, then they convert into some other energy form, right? So these sensor, if you have a sensor, basically sensor is also a transducer, actuator is also a transducer. So these sensors, they are going to take some input signals and then they are going to send to the processor. The processor will process the signal, right? And based on the results, probably, there will be some kind of an actuation that is going to take place. So this is typically the end-to-end kind of framework that is experienced in IoT. So a lot of different communication protocols have also been proposed for use in IoT networks. There are standards like 802.15.4, different other protocols and different other technologies which based on 802.15.4 standard like Zigbee, wireless HART, Z-Wave, etc. So like this, actually, there are many different communication protocols that have been proposed, right? Some are based on 802.15.4, some based on something else, right? So anyone knows what is Bluetooth based on? Which standard?
Eight not 2.11, so 11B.
So like this, actually, there are so many different communication protocols that are available. So now let us quickly have a look through. We are almost, yeah, so I just have some 10-15 minutes with me. So let me now switch my gear and come to the different works that we have been doing in the SWAN lab, right? So one of the works which has been primarily theoretical in nature, although we got some prototype implementations, is basically this sensor cloud, right? So in the same way as earlier on we talked about IoT cloud, here actually in sensor cloud we are talking about something called offering sensor services, sensing as a service, basically sensing as a service, right? So we all know about computers, computer virtualization, so computing resource virtualization, computing as a service, right? Computing is as a service is offered through these cloud computing technologies. So in the same way as cloud does computing as a service, we are talking about sensor cloud, which we are proposing will have, sensing as a service, right? So this is what you typically have at the very bottom. You have different, physical sensor nodes that are deployed, and these physical sensor nodes, they will have to, they sense the data, and these data will have to be processed, right? So the data will have to be processed. So how do you process the data and how do you make it available? How do you make the results of the processing available to the intended stakeholders? So for certain applications, it has been found that, if a particular owner, if a particular person has to use a, or if a particular person needs some kind of a sensor service, then traditionally they would have to procure the sensor devices, then deploy the network, maintain the network, and so on. So like that, everybody has to do the same, right? But for certain applications, it has been found out that you really need to do not need to procure separate networks, and you have to deploy them. So it is not required. So what you can do is that there will be some sensor cloud service providers who will be offering this sensor data as a service, and all you need to do is to subscribe through some portal, in the same way as you have cloud-based portals also. Here actually you will be subscribing through some portal, and you will be able to enjoy this different sensor data. Now, this technology is very attractive. I will tell you that lot of awards we have got, lot of success, lot of research papers we have got in IEEE transactions, etc. But the thing is that this scenario of offering sensing as a service has limited applicability. Not in all scenarios we can use sensing as a service, right? So there are certain limitations of it. So if you are interested to know more about Sensor Cloud, go to Google Scholar and search with my name with Sensor Cloud or Sensors as a Service, and then you will be able to get a lot of idea and also about the limitations that are there along with these technologies, right? So this is what Sensor Cloud talks about. So typically, this is kind of this is one of the best papers that you can use it as. So on theoretical modeling of Sensor Cloud is the paper that was published in IEEE Systems Journal by us. And in this particular paper, it was published, if I remember, it was in 2014 or 15, something like that. So I forgot to mention the year over here. So this particular paper basically gives you some of the foundational concepts that we have proposed in the context of Sensor Cloud, right? So yeah, and we have also given the theoretical modeling. The advantage is that so we were the ones to give the first theoretical model for Sensor Cloud, and the advantage is that the moment somebody has the theoretical model, further research becomes very easy, right? So we have provided that foundational work that will be required to carry on different analysis with Sensor Cloud. Right? So this is the scenario that you have. There is some kind of a user organization. So there are different applications that are running on top, and the user logs in and through some kind of a browser interface connects to the network, and then the sensed data is basically received by the user, right? So the user can access the sensed data, right? And this is a very simplistic view of the Sensor Cloud platform.
So is the received data processed also, or is it just raw data that is being shared with the user?
You can do whatever, so for us actually we were not processing, but you can, so if so this is, so we do not, so if required it can be processed, right? So it can be extended basically, so we do not process, we are just enabling the technology, but simple processing can definitely be done. Okay. So yeah, so there are different things that we have done and could be done. So like data aggregation is something. So you were talking about this processing, right? So you could do data aggregation. So different things like energy management, QoS, then sensor scheduling, and like that. Actually, there are so many different problems that have been identified, and we have also worked on a couple of them, and there are many others that remain unaddressed yet. So anybody wants to take up research on Sensor Cloud may be able to do or continue the research that we have been doing. So there are so many different problems. Theoretical modeling we have done, composition of virtual sensors. So ultimately, what happens is that you have different virtual sensor nodes, right? So these virtual sensor nodes, if you aggregate these virtual sensor nodes in certain composition, so ultimately, what you are going to get is some advanced levels of services at the application end, right? So these are possible. How you can optimally you can put these or integrate these different virtual sensor nodes. Caching is a very important thing, because let us say temperature, right? So let us say that you have a sensor network, a sensor cloud network, which does temperature sensing, right? So temperature is such a thing which doesn't change rapidly over time. So each and every unit, if you want to relay and offer, that will be more resource consuming. So instead, what you could do is you can cache the data, and if there is a change in the data, then only it can be made available to the users, right? So you are saving on the overall network or system bandwidth. So like this, actually pricing is also a very interesting thing. A lot of work has been done on pricing. One of the earliest works was done by one of my PhD students, dynamic optimal pricing for heterogeneous service oriented architecture for sensor cloud infrastructure in IEEE transactions on services computing. So here actually, so we come up with a pricing model, so which could be adopted. So it's a network pricing model basically, which could be adopted in order to use these sensor services or offer these sensor services. Very quickly, I'm going to run you through a couple of other works. So as I was telling you that we have a lot of footprint on healthcare. So one of the basic components of networking is the wireless body area network, right? In the context of healthcare. So wireless body area network is something like, a human being or a patient basically wears different physiological sensors, and these physiological sensors could be ECG sensor, EEG sensor, airflow sensor, body temperature sensor, blood pressure sensor. Like that, actually, there are so many different sensors that are commercially available in the market. So you use these small wearable sensors, and these sensors, they would be networked in a certain form. The data would be sent to some local processing hub like a smartphone or something, and from that smartphone the data could be sent to the cloud for further processing, storage, etc. Right. So this is how the wireless body area networks are formed. So these body area networks could be used for serving different healthcare applications, right? So different healthcare applications. So this is what I was talking about. So you have different physiological sensor nodes that the patient wears, and these nodes, they send sensed data to the local processing hub, and from this local processing hub, the data could be sent elsewhere. So here we are talking about intra WBAN communication. Intra means inside, right? So intra WBAN communication. So like this, if you consider different WBANs, you can have inter WBAN communication. So there are different access points that will have to come into the picture, and how you are going to make this entire network, etc. So for inter WBAN, you have technologies such as Zigbee, 802.15.4, the one that I was telling you earlier, or there is even a better one which is called 802.15.6, which is completely dedicated to healthcare applications. So this is another standard, 802.15.6 for healthcare applications. And for interband communication, you have Wi-Fi, cellular, etc. So there are so many different research challenges here as well, like dynamic channel conditions, right? So you are talking about patient who moves continuously. Limb movements are there. Not only limb movements, but also the entire body movement, and so on and so forth. So you have a completely dynamic channel characteristic, and sometimes you also have these nodes which are going to form the topology and break the topology continuously in real time. So how do you take care of this kind of network, right? So dynamic channel conditions, then reliability is very important, because you are talking about healthcare. It should not happen that somebody is getting a heart attack and the packet gets dropped, right? Reliability is very important. Heterogeneity of sensor devices. So I was earlier telling you that many of these devices that are used in IoT systems, etc., these are made by different vendors following different standards, which use different protocols. They, all of these standards, devices, protocols, etc., they do not as such talk to each other. So how do you make them talk to each other, while keeping in mind that there is the criticality of these sensor data. So the sensor data cannot drop. You cannot really prefer one type of data over another unless you have a certain medical condition in place, etc. So like that, actually, for fairness, etc., you need to have some kind of a fairness ensuring scheme. So like that, actually, there are so many different other research challenges as well. So considering all of these, we came up with different works have been done. So one of my students who is currently a faculty somewhere. So IEEE transactions on wireless communication in 2015, we have published this work on priority-based, priority-based data rate tuning. So basically, what happens is that there are so many, so to this local hub, there are so many different nodes which are trying to connect, right? At the same time, somebody is getting a heart attack and has a temperature and all of these things. So which packet should be given priority, which one not, right? So like that, actually, there is a game formulation, Nash bargaining game formulation that has been made, and it has been solved. And so this particular work, if you look through, you'll be able to get some idea about what we have done. So like this, actually, I'm skipping all of these in the interest of time. Like this, actually, there is another stream of works that have been done on nanosensor networks. So earlier, whatever we were talking about is basically, macro scale networks, right? So nanosensor networks talks about in a nanoscale in the human body, for example. So these different sensors that are going to be there are going to be injected into the bloodstream, for example, or are going to be deployed in certain locations of the human body. And so these sensors, they can self-organize, they can do their things on their own. They can communicate and they can continuously monitor the condition inside the human body. Right, so nanosensor networks are very popular, and we have here actually we have done a lot of work, using electromagnetic communication, using molecular communication, bacterial nano networks. Even one of my students presently, so first of all, she did some work on nano communication for dengue virus, right? So viral transmission inside the human body. So for dengue virus, she did. Then during the pandemic time, very recently, another IEEE transaction paper came out where she proposed a solution for modeling of transmission of COVID-19 virus inside the human body, right? So that also became very popular. So like that, actually, a lot of different works are possible, both on the electromagnetic aspects of communication as well as the molecular communication. So these research challenges that we experience and we have worked upon are listed over here. Again, in the interest of time, I'm not going to go through them. So let me skip all of these. These are actually some of our solutions only, and I'm not going to go through them. Yeah. So so let me skip this one too, and let me come to this one: UAV networks. Right. So UAVs, I think everybody knows what a UAV is, right? So unmanned aerial vehicles. So you must have heard about drones. So the drones basically are like flying helicopters where there is no, these are unmanned flying helicopters, right? So they come in different types. So there can be quadcopters, octocopters, etc., or there could be fixed wing drones, etc. So like that, so these drones, they themselves can be flown in isolation alone. They can be flown, or they can be networked together in order to fly them. So they have different interesting features. So they typically form an ad hoc network infrastructure less network. Ad hoc network is typically formed. However, so infrastructure based network can also be formed as it is written over here. So like that, actually, there are different things you can do with the networking of the drones, right? So this is a picture that I have taken. So we have done a lot of work on UAVs and UAV networks, and we have put everything on YouTube, right? So if you search with Drone Squad, Swan Group, IIT Kharagpur, like that, if you search, you will be able to find plenty of videos. So I'm not going to play these videos because they are going to consume time. But what I wanted to show you is this is actually from our helipad in IIT Kharagpur. So we used to do our experiments over there. So this is like two nodes in a network, right? Two nodes in a UAV network. So we started with 2 nodes, then we scaled up into 3 nodes, 4 nodes, and so on. So like that. Okay. So yeah. So this is basically this Swan sensor node. So we do not use it anymore because nowadays these open hardware platforms are available. But traditionally, we started with building our own IoT node, the sensor node, and we still use it for certain applications, like in agricultural application that we have. We still have this node being used, but most of the modern applications that we are working on, we have replaced this node with this open hardware platform-based nodes that can be developed very fast. These are actually more expensive, and developing them takes a lot of time. AmbuSense is a healthcare application that we have used of IoT. So basically, in our country, what happens is that patients will have to be taken from a rural healthcare center to a city hospital, right? If the condition of the patient is such that it cannot be treated in a primary healthcare center or a rural healthcare center, the patient will have to be taken in an ambulance. Many times it's not an ambulance. Also, it's like a simple, Omni van or something like that. There is no paramedic and so on, right? And for several hours, the patient will have to be taken from this primary healthcare center to the city hospital. And this journey typically is in the order of like 3 hours, 4 hours, 5 hours, and even more sometimes, right? So, if it is such a long journey, then many times, what happens, the condition of the patient is not monitored at all by any professional. So by the time the patient reaches the destination hospital, the patient dies, right? Or the severity of the ailment basically increases. So we came up with a solution by which the doctors at both the ends, so they are going to continuously monitor the condition of the patient being taken in the ambulance. And so if there is some kind of an intervention that will have to be given, the patient will have to be taken. And 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 the patient will have to the doctor can basically give this expert guidance. So this work has been popular. It has been published. It has been published in some IIT literature. It has been, the patents have been filed, and so like that. Actually, it is already being its derivative basically. Its derivative is being used for commercialization. Like that, actually, we are working on the different aspects of ambient sense. In agriculture, also we have a footprint. These are some real pictures of our deployed systems, right? This is basically a water level sensor that we have developed in-house, right? So these are from our agricultural fields where these nodes are different nodes are deployed. These are energy harvesting nodes, so these are solar powered, and energy harvesting they can run on their own. So like this, actually, there are some simulators also. So, and also we have worked on underwater acoustic nodes, right? So we have developed our own low-cost acoustic node. So typical most of these modems basically which are used underwater have to be imported, and typically most of these modems they cost like 5 to 6 lakhs or sometimes even 7 lakhs or even more, right? So we wanted to come up with a very low-cost Indianized version of these modems, and we started doing that. We had some success. We were able to get some level of success in the form of performance, etc. But then some parts of the system basically doesn't perform very well. So this is, but the good part is that this system, once it starts being functional, it can it's very cheap, right? So developing this node basically will take a couple of thousand rupees only, right? And it's not too bad, but it's little inferior to the commercially available systems. Some of these books actually, yeah. So Professor D'Souza, she mentioned about 2 books which I have not put over here. I forgot to change this slide. So there are two new books if you are interested. One, Cambridge University Press, published by Cambridge University Press, available on Amazon. It's Introduction to IoT. If you are interested, please feel free to buy a copy of the book. It is available through Amazon.in, or probably there are many other sites from where you can buy. There is another one which is Introduction to Internet of Things and Industry 4.0, published by CRC Press US, and it is also available now. It is also available through Amazon and a few other websites. So if you are not able to find any of these books, let me know, and I will be happy to share with you. So some of these media coverage and all of these stuffs, right? So different national newspapers, even in the televised media also, we have we were telecasted. Okay. So this is the most important slide. The reason being that so whatever I go and present, so most of these things have not been done exclusively by myself, right? So these are the these are the people, these are the students who actually do the work, and I am the one who go and present, right? So so the credit, basically most of the credit goes to these students who make things happen in real life. So thank you, Professor D'Souza. Over to you.
Yeah, thanks a lot, Professor Sudeep. Thank you very much.